Okay, so we're going to start with grading your histology lab. So this is your smooth muscle cells. You should have labeled, first of all, it should be pink and purple. It should have a title that says smooth muscle. It does not have to have a magnification. You should have labeled spindle-shaped cells, which are any of these cells that you can see in the longitudinal section. You should have labeled the top portion longitudinal section and the bottom portion cross section. And all of these purple dots are central nuclei. So you will give yourself 2 points for the sketch and 4 points for labeling, so 6 points total. Cardiac muscle, the light bands are going to be striations. The dark ones are intercalated discs. All of the cells are branching cells, but particularly it's talking about the fact that this cell starts here, but then it ends here and here, which is what branching means, so you should have labeled one of those. And all of the nuclei, particularly like these, are central nuclei. So intercalated discs, striations, branched cells, and central nuclei, 6 points total for this one. It should be pink, and it needs to have the title cardiac muscle. Next one, longitudinal section of skeletal muscle. Each of these horizontal lines is a muscle fiber, and the striations run perpendicular to those, so up and down. You should have labeled one of those as cylindrical cells, and then any of the nuclei are peripheral nuclei because they are stuck on the outside of the cells. Skeletal muscle, so this is a whole, there's a cross section and this is a whole piece of skeletal muscle, so a whole muscle. So the outside has epimysium. Any of these sort of discrete little pieces of it are fascicles. Around each fascicle is a perimysium. Inside the fascicles are muscle cells or muscle fibers, and around each muscle fiber is endomysium. Pick any dark purple dot like the ones I'm pointing to, and those are nuclei. So 2 points, 1 for saying skeletal muscle, 1 for making it pink, and then nuclei, muscle fiber, endomysium, fascicle, perimysium, epimysium. That looks like 3, 6, 7, 8 points for that one. A neuromuscular junction, so you have nerve fibers running into axon terminals. All of the nerve parts, so this part plus all of the axon terminals, is the motor unit. And all the pink parts are the skeletal muscle fibers. So that is also 6 points. All right. So that leads us to, just looking for a picture I took. There are 48 points on, do it here. So 48 points plus, hold on, I need a calculator. 48 points plus 6 plus 8 plus 5 plus 6 plus 6 is 79 total points for the lab. So you're going to do the thing where you do here. 79 minus the number wrong. And we'll underline that. I'm going to put that over 79. Divide that by 79. Nope. Yeah, divide that by 79. That will give you your percentage. And that is going to textbooks. Equal whatever it is that you equal times 50 equals your score. And I would like you guys to keep these labs, and you are going to hold on to them until you take your exam, and then you are going to give them to me when you take your exam, or if you're in CP, you can do it some other time. You can do it on Wednesday. Okay, so hold on to those, use them to study from because you have some star circles. All right, if you are in honors, we're going to talk about some few things. I'm not sure, I feel like we got this far, but we're going to talk about it really quickly. You should pause this and write these things down, and then I will tell you what you should know, and then you start it up again, and I'll tell you what you should know. So, the motor unit is like what we were just looking at, quite frankly. Let's just put that up, and then we're going to go someplace else. This is a motor unit, so like this nerve plus all of these axon terminals is a motor unit. This nerve is going to fire an action potential and cause all of these muscle fibers to contract, because this is acetylcholine. Those are those little black dots. Isn't that cool? And so a motor unit is a muscle has many different muscle fibers innervated by one motor nerve, and that is a motor unit. So the little muscles, like the ones that control your fine motor movements, so you may have heard about like fine motor development in maybe you took psychology. So little kids being able to pick little things up and write, that's all called fine motor movement. And then like being able to walk properly, like hit a baseball, catch a ball, throw a ball, those are all called gross motor movements, and those use much larger muscle motor units. So that's what this slide is talking about. And then each muscle itself is going to have multiple motor units. So we'll talk about recruitment in a bit, but if you want a little bit of a response, you might recruit send a message down one motor unit. But if you want a big motor response or a big muscle response, then you might send that message down multiple motor units, so you recruit more muscle fibers. All right, so that's segues nicely into our regulation of muscle contraction. A muscle twitch is best thought of if you've ever been to a PT, like a physical therapist appointment, and they've put the electric stim on you. It's two little pads that send a little electrical shock through it, and it causes little abbreviated muscle contractions across like a sore muscle or a tight muscle, or a muscle that you're trying to have some sort of isometric contraction that will not affect a joint if you have an injury in a joint. So there are 3 phases to that. You should write them down. When you're done writing, I will tell you that the latent period is this period here. This is the period where, let's go back. This is the period where here on the line, you got that message, the stimulus. So it was either the electrical signal from the electric stim or the message from your nervous system, and it caused calcium to come in, exocytosis of acetylcholine. It caused the acetylcholine to bind to the sodium channel, the sodium channel to open, depolarization to happen. If you're looking at your picture now, that's really a smart thing to do. Depolarization to happen, that depolarization to make action potential happen on the muscle cell, the action potential running along the sarcolemma, and then finally that down the T-tubule, the sarcoplasmic reticulum releases calcium. When it releases calcium, then the calcium binds to the troponin, it moves to tropomyosin, and now you can have cross-bridging. That is when you leave the latent period, and now you're in your period of contraction. So this is your excitation-contraction coupling. now you're having cross bridging, all of that good stuff that is causing the muscle to get shorter. So that happens in this span, but as soon as the calcium is released, it starts getting hoovered back up by the sarcoplasmic reticulum, and so therefore you are going to have sort of a period of relaxation that happens afterwards. So a single stimulus, that latent period is several milliseconds. This again is in milliseconds. And then the maximal contraction time is in 25, 30 milliseconds. And then after that, you have a waning period of relaxation as the calcium is reabsorbed. All right, so different muscles have different times that it takes them for them to fully contract with a muscle twitch, like a single stimulus. They all have the same latent time because that stuff that I just recited, and I'm not going to recite again, happens at the same rate no matter what. But some of the muscles recruit all the muscle fibers right at once and have a flexing and relaxing in a very brief amount of time. And these would be the motor movements, the muscles that need the fastest response. Your extraocular muscles are the muscles that attach to your eyeball and make them look side to side, up, down, perhaps allow you to see, someone who's lurking in the corner with a knife, and then you're scared. The gastrocnemius is your calf muscle, so this is your runaway muscle, so that's good. It recruits fast, but the duration is longer. And then the soleus is a support muscle, like you think about your core muscles, and it has you get that stimulus, you get a really slow start, and by slow I mean about 80 milliseconds, but then it lasts a really long time, which is great because you don't want to have to think about your core all the time. We have to think about our core enough. Can you imagine if you had to think about it all the time? So you just send yourself a message to sit up straight. Hopefully you are. You sit up straight, and you sit up straight for a longer period of time before you start to slouch, and then you have to remind yourself again. All right, so those are all muscle twitches. Graded muscle responses are really what what you use in your everyday. It's the difference between picking up a pencil and picking up a brick. It requires more muscle recruitment if you want to pick up the brick. And so that has to do with the amount of times you send a stimulation and the strength of the stimulation. So this is a great little diagram. It's figure 9.15 in your textbook, and it shows you that a twitch is this little muscle contraction. However, if you send a second signal down, as relaxation has started, but before it's like all over, then you get a bigger response. See how this peak is higher than that peak? It's because you're adding calcium, and so more muscle fibers are recruited. And then you have this period of time of, if you keep sending signals, you get an increased amount of strength. So think about picking something up. As you pick it up, it gets heavier. Like children, you have to lunge for it. And so as you do that, you send a bunch of different signals. And that's called unfused or incomplete tetanus. Tetanus is what happens, or tetany, happens when you are using your full strength. So this is like those people who deadlift like huge amounts and then hold it up over their head. That's what you need. You need number 4 is fused tetanus. You're sending all of the muscle signals as fast as you can to and which is why arm wrestling, you have to put like all of your exertion, including your mental work, into making that happen, because you have to keep sending those messages, and it is in fact taxing on your brain as well as your muscle. So these make a great matching section, so do in fact know them as well enough to do that. All right, so write this down. So threshold is the lowest amount of stimulus you need to get a contraction. We'll look at a picture of what that means in a second. And then, actually, let's just look at it since you wrote it down. So this is the voltage. So again, imagine you have your electric stim machine, and you may have done this. There's a point before where you say like you started on a 1, and you don't get any muscle response. You turn up the volts again to 2, still no muscle response. You turn it up to a 3. Oh wait, now you got a little bit of response. You got a teeny tiny twitch. Good. Then you turn it up to a 4, you got more than that. A 5, you get more than that. A 6, you get even more. 7, 8, and 9, you can keep turning that up, but you're never going to get more than this. You've created the maximal amount of contraction that you can do. So that's sort of where you top out. Eventually you'll create heat and cook that muscle, but that is, you can't get any more contraction and tension out of that muscle. Another thing about nuanced, you never recruit your biggest motor units first. So you can have sort of precision. You recruit the little ones first, and then the medium ones, and then the big ones. So if you're saying like, because you're never like, I want a giant response. If you want a giant response, you recruit all of them. If you want just a little response, you recruit the little ones. And if you want more, you just add bigger muscle motor units. So more fibers are recruited and you get more tension. So they start with the little ones. All right, treppy. Treppy is why you warm up. It is called the staircase effect. That's what treppy means. And it just means that if you have multiple stimuli of the same strength, so again, our little electric stim, you're going to get more response to it over time. And the answer to why is that there's more calcium outside of the sarcoplasmic reticulum. So more calcium, you're adding calcium to it. We just talked about that. But also you are making heat because of the muscle contractions, and that helps the enzymes work better because there's more energy in the system. So again, if you look at this, you have the same stimulus of the same voltage, but by the time you've done it 4 or 5 times, you're getting almost twice the amount of tension, twice the amount of muscle response that you did from the same stimulus. So again, this is why it's better to have more muscle contraction sort of to get going. It's like kind of one of the things behind momentum. Like once you already have your groove set, if you're like running or doing something, those muscles are already in use and they're warm, and it's really, some of it is in fact about the heat. It makes your muscles work more efficiently. All right, that is it. I would point you to, hold on, I would point you to Canvas, where in Canvas there is, on the pages, there is a resources for muscle contraction, and I will send over the right one. Nope. I will send over the right one from the other class, but there are all 5 videos to show you all of the illustration. This is a playlist that has a bunch of different cool animations that show you different points of view. I would use those to study from. And remember that there is a review after school on Wednesday, and I would be happy to have you guys there. All right. Happy solstice, everybody.